Welcome to my YouTube channels. So today I am going to solve the thermal stresses problem. Already previous video how to get the formula and what is thermal stresses we discussed. So just previous video you watch, then only you will understand this problem. So this problems I am going to solve very simple concept. So okay. So see here, what is the given data first we have to search. What is the given data? A rod 2 meter length. So length they given 2 meter. Temperature 10 degrees Celsius. Okay. Find the expansions of the rod. They are asking find the expansions of the rod when the temperature raised by T to 80 degrees Celsius at T1 is equal to 10 degrees Celsius given. If the expansion is prevented means they have to stop. Okay, so materials rod E given and linear coefficient of linear expansions both given. So okay, this both given, I am not writing, already value is there. So now what they are asking first, expansion they are asking. So expansion they are asking, already the derivations I solved. See here again I will revise little. Suppose this is rod is there, this temperature is 10 degrees there, this rod length is L, 10 degrees there. If temperature will increase up to 80 degrees Celsius, so what will happen, this expansions will be there. Now this is called delta L. That only they are asking. So that they are asking means what is the delta L here? So delta L depends upon the see here, directly proportional to change in temperature into length. So what is the delta L here? That only they are asking. What is? Find the expansions of the rod. So delta L they are asking. Suppose this will be equal to, this is proportional. Now this I am taking alpha. That means linear expansion, coefficient of linear expansion. Then what is temperature difference, delta T, and length. This is the formula will come. So what is this? 0.000040, yes, 12 into delta T, 80 minus 10. Because difference will be there na, you need not to convert Kelvin, only ratio and all we can. Suppose 80 minus 10, if you will convert Kelvin or degree, both will become same. So we kept like this. Length they given 2 meter. 2 meter. Okay. So unit will come. So no need to convert anywhere, no, meter, this delta T. So this if will solve, how much answer will come change in length? It will come, what is the answer here? 20. Answer is 0.168 centimeter. 0.168 centimeter. So first answer what is? Expansions of the rod this. So previous video I discussed these things. How to generate the formula. Again I wrote, but you can write in exams. What we can write formula? Directly you can write this formula itself. This is the formula for the expansions of the rod. But how this coming na? I told here. Okay, now next what they are asking? Stress induced. So stress formula, see here. Stress nothing but Young modulus into strain. So Young modulus into strain. What is the strain here? Strain formula how will get? You will see somewhere. Strain is equal to nothing but change in length by original length. Suppose this is strain, change in length by original length. What is here? Change in length, alpha delta T into L by L. So this got cancelled. What is this one? Strain. So what will be there? Alpha and delta T. This is the stress. So substitute all the value here. 1 into 10 power 5 mega Newton they given. So into 10 power 6 into alpha 0.00012 into change in temperature. Change in temperature, how much? 70 degrees Celsius. 70 degree. So if you'll, because this per degree Celsius, this degree Celsius, na, it will be Newton meter square will come. So how much stresses will come here? 84 Newton per mm square. 84 Newton per mm square. This is the stress, thermal stresses. Thermal stresses we got how much? We got this much, 84 point. So look here, how much simple. If you know this formula, if you know this formula, if you forgot this formula, you come here proportional, because this thermal stresses, this rod, change in length depends upon the temperature difference and length. Proportional na linear coefficient, coefficient of linear expansion into delta T into L. Once you know delta L, strain na change in length by original length. Stress, Young modulus into strain. Strain value substitute, you will get the answer. So, okay. And also you see, thermal stresses where the application. Suppose you will see this track, no, railway track. Railway track will be there. So what they will, you will see, no, somewhere track in between, some gap will be there. Why this gap will be there, no? Once here train will run, so due to this, temperature will increase in this track. Temperature will increase in the track and they will expand up to this, up to this. So for that only they are keeping the gap. So thermal stresses should not develop more. If thermal stresses will develop more, may happen anything, may bend, may accident will happen, may track will get damage, lot of things. So that's why you will see always between the two tracks some gap will be there to avoid the thermal stresses. Because once your heat will be there, na, definitely this length will change. Length will change. That's why they're giving the gap. But now recently you will see the lot of good materials came, na, somewhere they will not give gap also, because like this temperature resistance materials already came. But generally you will see some track in between, some gap will be there to avoid the thermal stresses. Thermal stresses definitely will develop due to thermal stresses only, should not happen any accident or any bending things. Okay, for that only they are giving. So, okay, so see here, students, you are watching these problems and all, how simple, but thermal stresses looks complicated. Students taking thermal stresses problem will not solve. But see, if you know the theorem, if you know the formula, how the formula is coming, basic concept, thermal stresses problem also you can solve very simple way. Okay, students? Okay, students, subscribe the channel, share this video to your friends so they can get also advantage for that. Okay, thank you.